All right, here we go. Section 9.5, logarithmic functions, also known as logs. Our goal for today is to be able to rewrite between logs and exponential form and vice versa, and then to evaluate. So, just a little thinking thing here to get us going. If 2 squared equals 4 and 2 to the third equals 8, then 2 to the what power would give us 6? Well, we have to know that it's between 2 and 3 because 2 to the second is 4, 2 to the third is 8, so somewhere in between those two numbers, but we don't really know for sure. But what we can do is use logs to figure it out. So what is a log? It's basically just how many of one number do we multiply to get to another number. So, for example, it helps us solve exponential equations with variables and exponents. That'd probably be a better way to say it. So how should we solve 2 to the x equals 8? If you don't know, you could convert it to a log and then, of course, use a calculator. So what we're going to do here is just practice quickly on how to convert between exponential form and log form. This would be read here, just so you know, as log base 2 of 8 is x, or x equals log base 2 of 8. So, rewriting these, this is going to be the important part. We've got to be able to jump back and forth so we can do some simplifying here, so we can do some solving as well. So log base 2 of 32 equals 5. So how can I write that to exponential form so maybe it means something to you? So what you do is you start by taking the base of your log. That becomes the base of your exponential equation. Then you take, I'll just keep highlighting here, then you take what it equals. That becomes the exponent. And then finally, you know 2 to the 5th, or hopefully you know 2 to the 5th is 32, but it comes from whatever is after your log base. Log base 2 of 32, so 2 to the 5th would equal 32. So highlighted here just to kind of show you where all of these things are coming from. And again, it's one of those things that just takes some practice. I wouldn't expect you to know exactly what's going on right away. We'll do another one here. So log base 10 of 1, so that's how you'd say that, equals 0. So again, to rewrite it so maybe it makes a little more sense, you start with the base of your log. That is the base of your exponential equation. Whatever it equals, that is your exponent. So we're saying 10 to the 0 power. That equals whatever number comes after your log. So in this case, it is 1. So log base, or log base 10 of 1 equals 0. Another way we could say or rewrite that, so it makes a little more sense, is 10 to the 0 equals 1. And hopefully you know that anything to the 0 equals 1. So the next one, I'll speed it up here. Oh, man. I'll speed it up here just a little bit. I'll highlight here because there are 2 9s. So we need to know where the 9s are coming from. But we would say 9 from right here. My base of my log is the base of my exponent. To the first power equals 9. The second 9 comes from right there. All right, so let's talk about the last example here. So we have log base 1/5 of 25 equals -2. So we would rewrite this as 1/5 to the -2 power equals 25. And just really quickly, if you remember how to handle those negative exponents, if you have a negative exponent, you would flip the fraction, so that would become 5 over 1 to the +2, which is 5 squared, or 25. So yes, it does indeed hold true. All right, so going from logs to exponential form, pretty easy. Let's see if we can go backwards. So we're starting in exponential form. We want to write it in log form. So the first thing you're going to want to do is write the word log. Then we're going to take the base of our log, that becomes, or the base of our exponent, our exponent there, and we are going to make that the base of our log. Whatever it equals, keep highlighting here, whatever that equals is the number after that, the log. And last but not least, log base 4 of 16 equals 2. That comes from my exponent. So again, one of those things that just takes a little practice. Let's try another one. So start by writing the word log. The base of the exponent here is the base of your log. So log base 2 of, what number goes after it? 8 equals, and then you take your exponent here, and there you go. Log base 2 of 8 equals 3. And even with that negative exponent, we can just rewrite it as a log right away. So we'll start by saying log base 2 of 1/8 equals -3. So that's just rewriting for you, but we also have to be able to evaluate. So let's take a look at a few examples here. We'll start with log base 3 of 81. So what we want to say is we want to figure out what this equals. So we're going to say equals x, because we don't know. You can use any variable you want, but we don't know. It equals x, some number. We're about to figure it out. So to do this, we want to rewrite it. So we're going to say 3 to the x power equals 81. Again, it goes back to those rules we just did. So the base here is the base of our exponent. Whatever number follows is what our exponential equation equals. And then whatever our log equals is our exponent. So 3 to the what power is 81. Now this one's pretty straightforward. You might know that it is 3 to the 4th. But we could take 81 and break it down. 9 times 9, and then 3 times 3, and 3 times 3. Then so how many 3's made up 81? If you count them out, we have 1, 2, 3, 4 of them, so that means x would equal 4. Log base 1/4 of 256 equals what? Okay, so we're going to start by rewriting this. So this would be 1/4 to the x power equals 256. So now here you got to be a little bit creative. Anytime you have, we'll just highlight this, fraction bases, or well, I'll talk about the next situation here in a second. But you're gonna have negative answers. I would expect negative answers anyway. If we're going from a fraction to a whole number or whatever. But we'll do the same thing. We'll break down 256. So we could go 64 times 4. This should be 8 and 8. Put the 4 up here. 4 and 2, 2 and 2. And then 4 and 2, 2 and 2, and then 2 and 2. So just breaking down 256. So here we want to know how many 4's we have, because our base involves a 4, so we're looking for how many 4's make up 256. So here's 1 4, because 2 times 2 is 4. Here's another. Here is another, and here is another. So there's 1 4, 2 4's, 3 4's, 4 4's. So just sidetracking really quickly, that means that 4 to the 4th power equals 256. But I want to know what 1/4 to what power equals 256. So in order to flip-flop our bases to go from 4 to 1/4, we would make this a negative exponent. So that means that x equals -4. All right, log base 10 of 0.001. So let's rewrite this, equals x, because we don't know. This would be 10 to the what power equals 0.001. Now, with a decimal problem like this, I would convert this to a fraction first. So that would be 1/1000. So we want to know 10 to the what power will give us 1,000. So again, you got to do the same thing. So we have 10 times 100 and then 10 times 10. You could keep breaking it down, but again, I want to know how many tens go into 1,000. So I have 1, 2, 3 of them. So what that means, again, same situation. So I'm going to, oh my goodness, I'm going to sidetrack here. So that means that 10 to the third equals 1,000, but I want to know 10 to the what power gives me 1 over 1,000. So same thing, in order to get that fraction, what we want to do is take that exponent, so it's not 10 to the third, but it would be negative 3. That's how you're going to make that from a whole number to a fraction. So there you go. And then one more example here. So we have 64 to the x power equals 2. So now we're going from a big base to a small number. So we're going kind of opposite here. So anytime this happens, you're going to have a fraction exponent. So it's going to be kind of like our situation over here and up here. But first we want to figure out how many times would 2 go into 64. So 2 times 2 times 2. How many times would 2 go into 64? So 2 to the 6th equals 64. We're going to work this backwards a little bit. So that means if I want to go from 64 to 2, that means my exponent now becomes a fraction. So it would be 64 to the 1/6 gives me 2. So that means that x would be 1 over 6. All right. Oops. Just a couple other things here before we just evaluate on a calculator in some cases here. So special log values. So if b is a positive number, our base, such that it's not 0, of course, because it has to be a positive number. The log of 1 would be 0, because anything to the 0 power is 1. The log of base b, so what it's saying here is if your base and the number following are the exact same, it's always 1. So just a quick example would be log base 13 of 13 is going to be 1. Log base 2 of 2 equals 1. That's always going to be the case. All right. So we have common logs and natural logs here. Common log is a log with a base of 10. So those of you that took, oh my goodness, those of you that took your ACT, you probably saw logs on there. And they were probably worded, sorry, I apologize here. You probably saw something like, evaluate log of 100. And so you don't see a base down there in that highlighted area. Anytime you don't see that base, it's always assumed to be 10. That's a common log. Same thing on your calculator. If you see the word log without a base, it is always assuming it's base 10. And then, of course, we have another one. So if we have a log of base e, that number e again is coming up, just like in the interest formula. If your base is e, we actually change it completely to ln, which weirdly enough stands for natural log. Of course, the L and the N would be backwards for that, but I didn't make that up. So, but yes, ln stands for natural log, and anytime you see that, it means that your base is e. Anytime you have common logs or natural logs, you feel free to use your calculator because those are already built in. So we're going to have to, so way over here on the left side, you see the word log. If you type it in, you notice right after the G, there's no base there, so it's assuming it's base 10. And with the ln right below it, that is the natural log. It doesn't show you a base, but it's assuming that it is that number e. So these we kind of already talked about quickly, but you'll notice how my base is different. It's 2, it's 4, it's a fourth, it's 32, and so on. So I'm going to just kind of set these up quick. I'll let you finish evaluating. So 4 to the what power equals 64. 1/4 to the what power equals 256. This would be 1/8 to the second power equal, or to the x power equals 2. And finally, 32 to the what power equals 2. So very similar to the examples we just did. Where like the first one, pretty straightforward. You break down 64. You want to know how many 4s go into that. So you would say 8 times 8, and 4 and 2, and so on. You would just keep breaking this down. And so how many 4s? Well, here 2 times 2 is 4. 2 times 2 is 4. 2 times 2 is 4. So that would be 4 to the third power. So we've done a few of those. There's a few more for you to take a look at, but just showing you how to evaluate these quickly. It says evaluate. Oh my God. All right, so you don't see a base here. That means we're assuming it is 10. And over here, because it's a natural log and there is no base, we assume that it is E. So you see those situations, you can go ahead and use your calculator. So on our calculator here, the log button is there on the left side. Oops. You would type in log, and then we want to know what the log of 7 was. You just type 7 in the parentheses, hit enter, and you'd find out that it is 0.85. It's approximately 0.85. And the natural log works the same way. So we're going to hit the natural log, and this one was 0.25. You hit enter, and it's negative 1.39 approximately. And again, that is because those bases aren't written down here. That's what we assume them to be. That's how you know you can go ahead and just grab your calculator and punch them in. And that will take care of section 9.